Okay, so we are ready to do the bottom of page 205 where it says other consequences. And it starts with a corollary there, corollary 2. Functions with f prime is equal to 0 are constant. Well, that makes sense, right? So if I have a function that is a constant, right? Any constant, I take the derivative of this, I'm going to get 0, right? I'm going to get 0, which makes sense. That's what they're saying, right? If f prime is equal to 0 at each point of an interval I, then there was a constant c for which f of x equal to c for all x is in I, okay? So actually another interesting thing here is that not only is it c, it's really any constant, right? I can go ahead and have a function that f of x is equal to 1, right? And if I take the derivative of that, my derivative is going to be 0. If I have a function that is f is equal to 101, right? I take the derivative, I'm still going to get 0, right? So I'm not am I really getting a constant? Am I getting a function? I'm actually getting a family of functions here, right? Any constant works, right? Okay, all right. So that's that. Let's go to corollary number 3. Functions with the same derivative. Oh, no, hang on a second. Before we go there. Yeah, okay. So functions with the same derivative differ by a constant. So if I have a function, let's say I have a function and I take the derivative. So the derivative of that function was cosine x. What would the original function be? Anybody? What function do I get cosine x?
Sine.
Huh?
Sine.
Sine. So sine x, right? Well, f of x equals sine x. When I take the derivative of this, I get that. Is that the only function that works?
Sine x plus anything? Sine x plus anything or minus?
Sine x plus anything. Sine x plus anything. In other words, this works, right? If I take the derivative of this, what do I get? I get that. If I take the derivative of this, I get that, right? If I take the derivative of this, I get that. In other words, again, when I'm looking at, if I start from here and I go backwards, okay, so I'm going backwards now, right? I'm not taking the derivative. I'm taking what is called the antiderivative, okay? If you look at the bottom of page 206, there is a thing called the antiderivative, okay? A function large f of x is an antiderivative of a function f of x if the large f of x prime is equal to f of x, okay? The process of finding that is called antidifferentiation. So what we're doing is called antidifferentiation. We are starting from this. We're doing antidifferentiation, and the correct answer is going to be sine x plus c. Okay, all right? Sine x plus c. So plus a constant. Any constant works here, right? Okay. So let's go to example number 7 and see if we can do this. Example number 7, since f has same relation, so we know that f has for some constancy. To identify, okay, never mind. Find the function f of x whose derivative is sine x and whose graph passes through the point 0, 2. So this is example number 7. We have been told that the derivative of a function is sine x. Is it sine x here? It is sine x. Sine x. So large f of x, the anti-differentiation is going to be what? What do I want to take the derivative for? What do I take the derivative to get sine x?
Negative cosine.
Negative cosine, exactly, right? Because if I take just the cosine, it would be negative sine. So by putting a negative on here, that gets rid of that negative. So I'm going to get negative cosine x plus the constant, right? But I've also been told that this goes through the point 0, 2. In other words, f of 0 is going to be equal to 2. So what is f of 0 here? When cosine x, what is cosine 0? In other words, cosine 0 plus c is going to be equal to 2, right? And I'm trying to find out what c is here. But I know that cosine of 0 is 1. So this is negative 1 plus c is equal to 2. Therefore, c is going to be equal to 3. So my final answer is negative cosine x plus 3. Okay, so this is going to be your final function. This is going to be your final answer here. Okay. Let's go ahead and do example 8. Okay, in example 8, we have find the velocity and position functions of a body falling freely from a height of 0 meters under under each of the following sets of conditions. A, acceleration is 9.8 meters per second squared, and the body falls from rest. So the body is falling from rest. So basically you have a body that is falling from rest, and I'm going to let go, and I'm going to just drop it like that. Okay, I was supposed to catch it, but I missed it. Let's try this again. Oh, okay. All right. So that's what we're talking about here. Free fall. So, and it starts at 0 here, and I'm going to drop it down like that. So my V naught is going to be 0 because I'm starting from free fall here, right? Starting from free fall here. Okay. So I'm starting from free fall, A, and I've been told that the acceleration, A, is equal to 9.8 meters per second squared, and it's going down this way. And it looks like the way this is set up is this is going to be positive going down this way and negative up here. So we're going down, and we're calling downwards as positive here. Okay, the acceleration is in the body falls from a rest. So we have velocity is a t, where v naught is the initial velocity. So it's going to be 0 plus 9.8 t. Okay, this is going to be your v. So this is going to be 0 here. So we're going to, this is going to be it. So your position is going to be what? If I take the derivative of this, I'm supposed to get v, right? So now I'm looking to find the antiderivative of this. What, when I take the derivative, gives me this? So it's going to have to be t squared, right? So when I take a t squared derivative, I'm going to get a t, right? But I need to get 9.8 in the end. So I'm going to start with half of that, 4.9, right? If I take the derivative of that, the 2 comes over, becomes 9.8 t. Then obviously there's a constant here, right? Because it works with any constant. I can work with any constant. However, I am told that falls from rest, and rest is going to be 0. So when t is equal to 0, this is 0. I mean, I'm going to get 0, right? I need to get 0. So 4.9 times 0 squared plus c is going to be equal to 0. So c is going to be equal to 0 also. So my final answer is going to look like that. That's going to be my position function right there. Okay, that's good. And now in B, I'm propelled downward. So I'm going down and I'm pushing it down with an initial velocity of 1 meters per second. Okay, so now instead of this being 0, I actually do have a V naught of 1. Okay, so this is B now. This is B, okay? So now I actually have since going downwards was positive, okay, so I have 1 plus 9.8t. So now let's go ahead and find the antiderivative of this. So the antiderivative is going to be what? So this stays the same, and I have to add that, right? Because when I take the derivative of t, I get 1, right? If I take the derivative of t, I get 1. I take the derivative of this, I get that, but there's also the constant, any constant, right? And again, I'm going to start from rest. So when t is equal to 0, I should be 0. So I get 0 plus c is equal to 0. Therefore, c is equal to 0. Therefore, this c goes away. And that is my final answer. And yeah, that's good. We're good. Okay. All right. So antiderivatives. Make sure you get this down pretty as well as you can, because all of next semester is going to be spent on antiderivatives. Okay. All right. Any questions? Any questions?